Hello friends, welcome to Python tutorial. This is our first tutorial of the Python language. Let's start with the introduction of Python. First part of the introduction, which is history of the Python. Judo Van Rossum, the creator of Python language. Python was conceived in the late 1980s and its implementation was started in December 1989 by Judo Van Rossum at CWI in the Netherlands as a successor to the ABC language itself inspired by SEDL, capable of exception handling and interfacing with the ARM operating system. Different versions of Python language like Python 2.0, Python 3.0, Python 2.6, Python 2.7 and many more. Python has been awarded a TIOBE Programming Language of the Year award twice, 2007, 2010, which is given to the language with the greatest growth in popularity over the course of a year as measured by the TIOBE index. Now friends, we see the features of Python language. There are many features of Python. It is a multi-paradigm programming language. It is also object-oriented programming, structured programming, functional programming, aspect-oriented programming, and dynamic name resolution. It is also called a late binding, which binds a method and variable names during program execution. Map, reduce, and filter functions, comparisons for lists, dictionaries, and sets, as well as generator expression. Now we see how to open the Python 2.7. This is the path for open the Python 2.7. Now we see practically how to open the Python 2.7. First of all, go into Start menu and select on all programs and then select the Python 2.7 and select Ideal Python GUI, and we have the screen of Python shell on our main window. We will learn about the basic of Python. Python is a dynamic language. Here we have installed Python 2.7.3 in our Windows machine. Let's write a hello world program in Python, which is way more easy than writing it in any other programming language. All have to do type print, then double quoted and write hello world, and then complete the double quoted and press enter. There we see hello world is print on the screen. Now we see the description. A simple general purpose scripting language good for writing a short program. Python is interpreted, which means that Python code is translated and executed by an interpreter, one statement at a time, as described earlier in the chapter. Python is an object-oriented programming language. Data in Python are objects created from classes. There are many special characters. First one is opening and closing parentheses used with function. Then pound sign precedes a comment line. Opening and closing quotation marks encloses a string. And paragraph comments encloses a paragraph comment. Now we do some practical part. Now let's do some arithmetic operator. Now let's do some arithmetic operator, and the way we do that also very much easier than any other programming language. Just press 10 plus 20 and press enter. It is 30. So now if you want to build some program which have very easy interface and runs very faster, Python is a great language to choose. Now let's take some input from user and process it. We have a function called row input, but before that we have to understand what is a variable. You know any other languages that variable stores a value which can be changed inside a program. To declare and define a variable in Python is very easy. Let's say x is equal to 10 and press enter. X is assigned as 10. Now whenever you will go and type x plus anything like 10, it will take x as 10 plus 10 is equal to 20. And now let's take some input from user. As we have talked earlier, y is equal to row input in the quotation, enter the value of y, complete the double quotation and press enter. Is print enter the value of y, so it will say enter the value of y and let me give it 15. X is assigned 10 and y is assigned 15. If you press x plus y and it gives a error because x was an integer and y was a string. Now to solve this, we can do it in this way. X plus int y and press enter. It will take x and the integer from y and then it will sum of them and 25. This was very basic tutorial about Python. We have included the arithmetic operation, typecasting, user input as well. This will give you idea of how Python tutorials will go on and teach you Python. There are many built-in functions in Python language. ABS, it returns the absolute value of x. Max, it returns the largest value among the x1 and x2. Min, returns the smallest value among x1 and x2. Pow, it returns the a raised to b. Round, returns an integer near x to x. If x is equally close to two integers, the even one is written. The another round is returns the float value rounded to n digits, the decimal point. Now we see the mathematical function. There are many mathematical functions like fabs, ceil, floor, exp, log, square root, cos, sine, and many more. For drawing the various shapes, there are many functions like turtle forward, turtle backward, turtle right, turtle left, turtle go to, turtle set x, turtle set y, turtle set heading, turtle home, and many more. Now we see practically how the built-in function is work. First of all, we see how the ABS function is work. ABS, in the bracket we write the -2. It will give the answer 2. Now we find the max value, max 1, 5, 9 and press the enter. It will give the 9, which is the maximum number. And now we see the mean function. The same value 1, 5, 9, it will give the 1, which is the lowest value among them. Now we see how the mathematical function is work. To work that, first of all we write the for statement import math and press enter. And now we see how to fabs function is work. Write math dot fabs in the bracket we write -2 and press enter. It will give the float value. Now we see cell function math dot cell in the bracket we write 2.1. It gives the answer 3. It is round the value 2.1 up to its nearest integer and return that integer. Now we see some code for design. First of all, we write import turtle, then press enter. Then we write the code turtle dot pen up, turtle dot go to -100 to 50, then turtle dot pen down, then turtle dot circle in the bracket 40, and steps is equal to 4 and bracket complete turtle done. Then press enter and we see the output on the screen. First of all, we see the if statement. A one-way if statement executes the statements if the condition is true. Python has several types of selection statement, one-way if statements, two-way if else statement, nested if else statement, multi-way if else statements, and conditional expression. A one-way if statement executes an action if and only if the condition is true. The syntax for a one-way if statement is if and boolean expression, then write the statement. If the boolean expression evaluates to true, the statement in the if block are executed. For example, we see the if radius greater than equal to 0, then area is equal to radius into math.py and the print the area of the circle and the radius. Now we see the two-way if-else statement. A two-way if-else statement decides which statements to execute based on the whether condition is true or false. A one-way if statement takes an action if the specified condition is true. If the condition is false, nothing is done. But if you want to take one or more alternative action when the condition is false, you can use two-way if-else statement. Here is the syntax for a two-way if-else statement. First of all, we write if and the boolean expression, then write the statement, then else and write the statement. Now we see the nested if and multi-way if else statement. One if statement can be placed inside another if statement to form a nested if statement. The statement in an if or if else statement can be any legal Python statement, including another if or if else statement. The inner if statement is said to be nested inside the out if statement. The inner if statement can contain the another if statement. In fact, there is no limit to the depth of the nesting. For example, the following is a nested if statement. If I greater than k and if j greater than k, then print I and j are greater than k, else print I is less than or equal to k. The if j greater than k statement is nested inside the if I greater than k statement. Now we see the one program of if statement practically. First of all, we write the number is equal to integer in the bracket row input, then other bracket, and write enter the number and the complete the bracket, hit enter and let it gives the value 45 and write if number modulo 5 is equal to 0 and then colon print high 5 if number modulo 2 equal to 0 and then colon print high even and hit the enter. Here we have the value high 5 because it is divisible by 5 but not divisible by 2. Friends, our next topic is loops. There are many type of loops like while loop, for loop, do while loop, nested loop, and many more. First of all, we see how the while loop is works. A while loop executes a statement repeatedly as long as a condition remains true. The syntax for the while loop is shown in the figure where while and loop continuation condition and the loop body and the write the statement. Now we see the for loop. A Python for loop iterates through each value in sequence. Often you know exactly how many times the loop body needs to be executed, so a control variable can be used to count the execution. A loop of this type is called a counter control loop. In general, the syntax of a for loop is for variable in and sequence and the right loop body. The variable var takes on each successive value in the sequence, and the statements in the body of the loop are executed once for each value. Now friends, we see the nested loops. A loop can be nested inside the another loop. Nested loops consist of an outer loop and one or more inner loops. Each time the outer loop is repeated, the inner loops are retrieved and started new. There are two keywords, break and continue. The break and continue keywords provide additional controls to a loop. You can use the keyword break in a loop to immediately terminate a loop. The continue keyword ends only the current iteration. Now we see how these loops are work practically. First of all, we see the while loop. Here initialize sum is equal to 0, I is equal to 1, and write the condition while I less than 10 and colon, and sum is equal to sum plus I, and I is equal to I plus 1. Then print sum is double quoted complete and print the sum and hit enter. Here we see the output of the following code. Our final answer is 45. Now we see how the for loop is work. First of all, we write the for v in range, and we give the value like 3, 9 and 2, and give the colon and print v and hit the enter. We see the output 3, 5 and 7. About the function. First of all, we see how to define a function. A function definition consists of the function name, parameters and body. The syntax for defining a function is as follow: definition, function name, in the bracket, list of parameter and the function body. We see the one example of define a function: def max num1 and num2, and in the function body, if num1 is greater than num2, then result is equal to num1, else result is equal to num2, and return the value of result. Now we see the main topic of function is called stacks. Each time a function is invoked, the system creates an activation record that stores its arguments and variables for the function and places the activation record in an area of memory known as a call stack. When a function calls another function, the caller's activation record is kept intact and a new activation record is created for the new function call. Now we see the different type of functions. There are functions without return values, positional and keyword arguments, passing arguments by reference values, default argument, and returning multiple values. Now we see the function with and without return values. A function does not have to return a value. Technically, every function in Python return a value whether you use return or not. For this reason, a function that does not return a value is also called a none function. The none function value can be assigned to a variable to indicate the variable does not reference any object. For example, def sum in the bracket number1 and number2 is set to argument, and the total is equal to number1 plus number2, and print the answer. you will see the output is none because the sum function does not have a return statement. By default, it returns none. Next, we see the positional and keyword arguments. A function arguments can be passed as positional argument or keyword argument. The power of a function is its ability to work with parameters. When calling a function, you need to pass arguments to parameters. There are two kinds of argument, positional arguments and keyword arguments. Using positional argument requires that the argument be passed in the same order as their respective parameters in the function header. For example, definition and print ln in the bracket message and variable n and for I in range and print the message. The following function prints a message for n times. Now we see the passing arguments by reference value. When you invoke a function with arguments, each argument's reference is passed by value to the parameter in the function. The reason is that numbers and strings are known as immutable objects. The contents of immutable objects cannot be changed. Because all data are objects in Python, a variable for an object is actually a reference to the object. When you invoke a function with argument, the reference value of each argument is passed to the parameter. This refers to as pass by value in terminology. The value is actually a reference value to the object. Whenever you assign a new number to a variable, Python creates a new object for the new number and assigns the reference of the new object to the variable. We'll learn about the strings. The focus of this tutorial is on class design using Python's str class as an example and exploring the role of special methods in Python. First of all, we see how to create a strings. You can create a string by using the constructor as follow. We declare s1 is equal to str and s2 is equal to str and welcome. In other way, Python provides a simple syntax for creating a string object by using a string value. For example, s1 is blank string and s2 is equal to welcome. A string object is immutable. Once it is created, its contents cannot be changed. To optimize performance, Python uses a one object for string that have the same content. Next, we see the concatenation and repetition operator. You can join or concatenate two strings by using the concatenation operator, means the plus operator. You can also use the repetition operator to concat the same string to multiple times, means multiple operator. Now we see the in and not in operator. You can use the in and not in operators to test whether a string is in another string. Here are some examples. S is equal to input, enter a string. If Python in S, then print the Python and is in, else the Python is not in. Now we see how to compare the two strings. You can compare the strings by using the comparison operator like double equal to, not equal to, less than, greater than, less than equal to, and greater than equal to. Suppose you need to compare the strings S1 Jan with S2 Jack. The first character J versus J, S1 and S2 are compared because they are equal. The second two character A versus A are compared because they are equal. The third word two character N has a greater ASCII value than K. S1 is greater than the S2. Then we see the formatting string. There are many functions for formatting the string. First one is center. This function is returns a copy of the string center in a field of the given width. The second one is ljust, returns a string left justified in a field of the given width. The next one is rjust. It gives the returns a string right justified in a field of the given width, and the format function it format a string. Now we do some practically. Now we see practically how the simple string is work. First of all, we initialize s is equal to welcome and hit enter. Then write len into bracket s and press enter. It gives us 7. It is the length of the string. Then write the max in the bracket s and press enter and hit enter. Lowercase letters have a higher ASCII value than the uppercase letter, so we have the get the answer W. Then we write the main function S. It gives the answer as C. Now we see the example of concatenation and repetition operators. We initialize S1 is equal to welcome, S2 is equal to Python. Now we have write the S3 is equal to S1 plus in double quoted 2 plus S2. Enter and we write to print S3 where our output is welcome to Python. SM we initialize S4 is equal to S1 into 3 and hit the enter and print the S4, so our output is welcome is print for the 3 time. This is the basic of the strings. We learn the errors and exception. There are many type of handling errors and exception. Syntax error, exceptions, handling exception, raising exception, user defined exception, defining cleanup action, predefined cleanup action. Now we see the syntax error. The raise statement allows the programmer to force a specified exception to occur. Here we see the example of raising the exception. The parser repeats the opening line and display a little arrow pointing at the earlier point in the line where the error was detected. The error is caused by the token preceding the arrow. In the example, the error is detected at the keyword print since a colon is missing before it. Now we see the syntax error. Syntax error, also known as pricing errors, are perhaps the most common kind of complaint you get while you are still learning Python. There are the simple code for syntax errors. You will soon learn how to handle them in Python programs. Most exceptions are not handled by programs, however, and the result in error message as shown here. While true print hello world and file stdin line 1 in. It is a syntax error. Now we see the exception. Even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. Errors detected during the execution are called exception. Here the simple code for exception. It is possible to write a programs that handle the selected exception. Look at the following example which asks the user for input until a valid integer has been entered but allows the user to interrupt the program. Note that a user generated interruption is singled by raising the keyboard interrupt exception. Now we see the handling exception. There are the try statement work as follow. First, the try clause is the statement as between the try and except keyword is executed. If no exception is occurs, the except clause is skipped and execution of the try statement is finished. If an exception occurs during the execution of the try clause, the rest of the clause is skipped. Then, if its the type matches the exception name after the expect keyword, the except clause is executed, and then execution continues after the try statement. The solve argument to raise indicates the exception to be raised. This must be either an exception instance or an exception class. We learn about the classes and object. First of all, we see the classes. Compared with other programming languages, Python class mechanism adds classes with a minimum of new syntax and semantics. It is a mixture of the class mechanism found in C++ and Modula 3. Python classes provide all the standard features of object-oriented programming. The class inheritance mechanism allows a multiple base classes. A derived class can override any methods of its base class or classes, and a method can call the method of a base class with the some name. Object can contain arbitrary amounts and kinds of data. Classes introduce a little bit of new syntax, three new object types, and some new semantics. The simplest form of class definition looks like this: class, class, name, then statement, and then to statement n. Class definition, like function definition, must be executed before they have any effect. When a class definition is entered, a new namespace is created and used as the local scope. Thus, all assignments to local variables go into this new namespace. When a class definition is left, normally a class object is created. This is basically a wrapper around the contents of the namespace created by the class definition. Now we see the class objects. Class objects support two kinds of operation: attribute reference and instantiate. Attribute references use the standard syntax for all attribute references in Python, obj.name. The class definition look like this: class, my class, then a simple example class, then I is equal to 1, 2, 3, 4, 5, and call the function definition f itself and return the hello world. Then my class I and my class f are valid attribute references returning an integer and a function object respectively. Class attributes can also be assigned to, so you can change the value of my class I by assignment class. Class instruction uses a function notation. Just pretend that the class object is parameterized function that returns a new instance of the class. Now we see the method of objects. The only operation understood by instance objects are attribute references. There are two kinds of valid attribute: names, data attribute, and methods. Data attributes correspond to instance variables in Smalltalk and to data members in C++. Here we see the small code for objects. Data attributes need not be declared like local variables. They spring into existence when they are first assigned. We learn about the inheritance. A language feature would not be worth of the name class without supporting inheritance. The syntax for a derived class definition looks like this: class, derived class name, and in the bracket base class name, then statement 1 to statement n. The name base class name must be defined in a scope containing the derived class definition. In place of a base class name, other arbitrary expressions are also allowed. This can be useful, for example, when the base class is defined in another module, class, derived class name, and in the bracket more name dot base class name. Execution of a derived class definition proceeds the same as for a base class. When the class object is constructed, the base class is remembered. This is used for resolving the attribute's reference. If a requested attribute is not found in the class, the search proceeds to look in the base class. This rule is applied recursively if the base class itself is derived from some other class. Derived classes may override methods of their base classes because methods have no special privileges when calling other methods of the same object. A method of a base class that calls the another method defined in the same base class may end up calling a method of a derived class that overrides it. Python has two built-in functions that works with the inheritance. The first one is use is instance. It is check an instance type, and the second one is subclass is to check class inheritance. Now we see the multiple inheritance. Python supports a limited form of multiple inheritance as well. A class definition with multiple base classes looks like this: class, derived class name, and in the bracket base class name 1, base class name 2, base class name 3, and the right statement 1 to statement n. With new style classes, dynamic ordering is necessary because all cases of multiple inheritance exhibit one or more diamond relationship. For example, all new style classes inherit from object, so any case of multiple inheritance provides more than one path to reach object to keep the base classes from being accessed more than once. We learn about the list. First of all, we see the basics of list. A list is a sequence defined by the list class. It contains the methods for creating, manipulating, and processing list. Elements in a list can be accessed through an index. Like example, list 1 is equal to blank, list 2 is equal to 2, 3, and 4, which is an integer type, list 3 is equal to red and green, which is a string type. Now we see the more knowledge about the list. There are many functions of the list like list append. It is add an item to the end of the list. Second one, list extend. Extend the list by appending all the items. Insert. Insert an item at a given position. The first argument is the index of the element before which to insert. The next one is list remove. Remove the first item from the list whose is X. List pop removes the item at the given position in the list and return it. If no index is specified, removes and returns the last item in the list. List index. Return the index in the list of the first item whose value is X. List count. Return the number of times X appear in the list. And last one is list sort, which is sort the item of the list in place. The list is also using as a stack and as a queue. Now we see the practically how it is used. We write some code for see the stack. First of all, we initialize stack is equal to 3, 4, and 5. Now we append the value stack dot append, and let me give it value 6, and another value is append stack append, and let me give it 7, and now we print the stack. We have value 3, 4, 5, 6, and 7. Now we pop the element in the stack. We write stack dot pop, and now gives a value. It is pop the 7, and now again we print the stack. Then we get the value 3, 4, 5, and 6. 7 is be deleted because we have used the formula stack pop. The list method make it very easy to use a list as a stack where the last element added is the first element retrieved, last in, first out. To add an item to the top of the stack, use append. To retrieve an item from the top of the stack, use pop without an explicit index. It is also possible to use list as a queue where the first element added is the element retrieved, first in, first out. However, lists are not efficient for this purpose, while appends and pops from the end of the list are fast. Doing insert or pops from the beginning of a list is slow. This is the example of using the list in a stack. We learn about the polymorphism and dynamic binding. The three pillars of object-oriented programming are encapsulation, inheritance, and polymorphism. You have already learned the first two. This tutorial introduces about the polymorphism. Polymorphism means that an object of a subclass can be passed to a parameter of a superclass type. A method may be implemented in several classes along the inheritance chain. Python decides which method is invoked at a runtime. This is known as dynamic binding. You have already used inheritance to model a relationship. We now explore other relationship. Now we see the isInstance function. The isInstance function can be used to determine whether an object is an instance of a class. You can fix this problem by using Python's built-in in function. This function determines whether an object is an instance of a class by using the following syntax: is instance in the bracket object and class name. Now we see the class relationship. To design a classes, you need to explore the relationship among the classes. The common relationships among the classes are association, aggregation, composition, and inheritance. First one is association. Association is a general binary relationship that describes an activity between two classes. For example, a student taking a course is an association between the student class and the course class, and a faculty member teaching a course is an association between the faculty class and the course class. Now we see the aggregation and composition. Aggregation is a special form of association that represents an ownership relationship between two objects. Aggregation model has relationships. The owner object is called an aggregating object and its class is called an aggregating class. The subject object is called an aggregated object and its class is called an aggregated class. An object can be owned by several other aggregating objects. If an object is exclusively owned by an aggregating object, the relationship between the object and its aggregating object is referred to as a composition. For example, a student has a name is a composition relationship between the student class and the name class, whereas a student has an address is an aggregation relationship between the student class and the address class, since an address can be shared by the several students. Tuples are like lists, but their elements are fixed. That is, once a tuple is created, you cannot add new elements, delete elements, replace elements, or reorder the elements in the tuple. You create a tuple by enclosing its elements inside a pair of parentheses. The elements are separated by commas. You can create an empty tuple and create a tuple from a list. If the content of a list in your application should not change, you can use a tuple to prevent elements from being added, deleted, or replaced accidentally. A tuple is very much like a list, except that its elements are fixed. Furthermore, tuples are more efficient than lists due to Python's implementation. As shown in the following example, t1 is equal to blank, t2 is equal to 1, 3, and 5. and T3 is equal to tuple 2 into x for x in range 1 and 5. Now we see the sets. Sets are like lists in that you use them for storing a collection of elements. Unlike list, however, the elements in a set are non-duplicates and are not placed in any particular order. Creating sets. You can create a set of elements by enclosing the elements inside a pair of curly braces. If your application does not care about the order of the elements, using a set to store elements is more efficient than using a list. Due to Python's implementation, this tutorial introduces how to use set. The elements are separated by commas. You can create an empty set or you can create a set from a list or a tuple. Now we see manipulating and accessing sets. You can add an element to a set or remove an element by using the add or remove method. You can use the len, min, max, and sum function on a set and a for loop to traverse all elements in a set. You can use the in or not in operator to determine whether an element is in the set. Now we see subset and superset. A set S1 is a subset of S2 if every element in S1 is also in S2. You can use the S1 is subset method to determine whether S1 is a subset of S2. S1 in the following code. S1 is equal to 1 to 4 and S2 is equal to 1, 4, 5, 2 and 6. We fire the query S1 is equal to S1 dot is subset S2, then it gives the value true. Now we see the comparing the performance of sets and lists. Sets are more efficient than lists for the in and not in operator and for the remove method. However, sets do not support the index operator because the elements in a set are unordered. The elements in a list can be accessed using the index operator. To traverse all the elements in a set, use a for loop. Now we see the dictionary. A dictionary is a container object that stores a collection of key value pairs. It enables fast retrieval deletion and updating of the value by using the key. First of all, we see the creating a dictionary. You can create a dictionary by enclosing the items inside a pair of curly braces. Each item consists of a key followed by a colon followed by a value. The items are separated by commas. Brief tour of the standard library. The first one is output formatting. The REPR module provides a version of REPR customized for abbreviated display of large or deployed nested containers. Here we have the example on the screen. The pprint module offers a more sophisticated control over printing both built-in and user-defined objects in a way that is readable by the interpreter. When the result is longer than one line, the pretty printer adds a line, breaks, and indentation to more clearly reveal data structure. We have the some coding on the screen which will give the output. Now we see the text wrap module formats paragraph of text to fit a given screen width. We have the coding for it. Import text wrap and doc is equal to double quoted. The wrap method is just like a fill except that is returns an extra. It is given the value and it is print on the screen. The local module classes access a database of cultural specific data formats. The grouping attribute of locals format function provides a direct way of formatting numbers with group separators. Now we see the templating. The string module includes a versatile template class with a simplified syntax suitable for editing by end users. This allows the user to customize their application without having to alter the application. The format uses placeholder names formed by the dollar sign with the valid Python identifiers surrounding the placeholder with the braces allows it to be followed by more alphanumeric letters with no intervening space. Writing double dollar sign creates a sign escape dollar sign from string import template and then write the coding and we get the output. The substitute method raises a key error when a placeholder is not supplied in a dictionary or a keyword argument. For mail merge style application users, supplied data may be incomplete and the save substitute method may be more appropriate. It will leave placeholder unchanged if data is missing. Template subclasses can specify a custom delimiter. For example, a batch remaining utility for a photo browser may elect to use %signs for a placeholder such as the current date, image, sequence, number, or file format. Another application for templating is separating program logic from the details of multiple output formats. This makes it possible to substitute custom templates for XML file, plain text, report, and HTML web reports. Now we're working with the binary data record layouts. The struct module provides a pack and unpack function for working with variable length binary record formats. The following example shows how to loop through header information in a zip file without using the zip file module. Backcodes H and I represent the 2 and 4 byte unsigned numbers respectively. The less than signs indicates that they are standard size and little and in byte order. Now we see the multi-threading. Threading is a technique for decoupling tasks which are not sequentially dependent. Threads can be used to improve the responsiveness of applications that accept user input while other tasks run in the background. A related use case is running I/O in parallel with computation in other thread. The elements of expression in Python. The first one is arithmetic conversions. When a description of an arithmetic operator below uses the phrase, the numeric arguments are converted to a common type. The arguments are coerced using the coercion rules listed at coercion rules. Extension can define their own covariance. If both arguments are standard numeric types, the following concurrents are applied. If either argument is a complex number, the other is converted to complex. Otherwise, if either argument is a floating point number, the other is converted to a floating point. Otherwise, if either argument is a long integer, the other is converted to long integer. Otherwise, both must be plain integers and no conversion is necessary. Now we see the atoms. Atoms are the most basic elements of expression. The simplest atoms are identifiers or literals. Forms enclosed in reverse, quotes or in parentheses, brackets or braces are also categorized syntactically as atoms. Here we see the example of atom. Now we see the identifier. An identifier occurring as an atom is a name. When the name is bound to an object, evaluation of the atom yield that object. When a name is not bound, an attempt to evaluate it raises a name error exception. When an identifier that textfully occurs in a class definition begins with two or more underscore character and does not end in two or more underscores, it is considered a private name of that class. Private names are transformed to a longer from before code is generated for them. Literals. Python supports strings, literals, and various numeric literals. Here we have see the Syntax for the literal. Now we see the parenthesized forms. A parenthesized form is an optional expression list enclosed in parentheses. Parenthesis form is equal to in the bracket expression list. A parenthesized expression list yield whatever that expression list is. If the list contains at least one comma, it yields a tuple, otherwise it yields the single expression that makes up the expression list. An empty pair of parentheses yield an empty tuple object. Since tuples are immutable, the rules for literals apply. Now we see the list displays. List display is a possibly empty series of expressions enclosed in a square bracket. Now we see the generator expression. A generator expression is a compact generator notation in parentheses. The syntax for generator expression is expression comp for. A generator expression yields a new generator object. Its syntax is the same as for comparison, except that it is enclosed in a parenthesis instead of brackets or curly braces. Now we see the string conversion. String conversion is an expression list enclosed in a reverse quotes. String conversion is equal to in the double quoted expression list. A string conversion evaluates the contained expression list and convert the resulting object into a string according to rules specific to its type. These many different types. Statement. First of all, we see the type of statement. There are many type of statements in the Python language. Expression statements, assignment statement, the assert statement, the pass statement, the deal statement, the print statement, return statement, yield statement, raise statement, break statement, continue statement, and many more. Now we see this statement in the deep. First is the expression statement. Expression statements are used to compute and write a value or to call a procedure, return no meaningful result. Other uses of expression statements are allowed and occasionally useful. The syntax for an expression statement is expression statement is equal to expression list. The next one is assignment statement. Assignment statements are used to bind names to values and to modify attributes or items of mutable objects. Like example, assignment statement is equal to target list plus expression list or yield expression. Assignment of an object to a target list is recursively defined as if the largest is a single largest, the object is assigned to that target. If the target list is a comma-separated list of targets, the object must be an iterable with the same number of items as there are targets in the target list, and the items are assigned from left to right to the corresponding target. An assignment statement evaluates the expression list and assigns the single resulting object to each of the target list from left to right. Now we see the assert statement. Assert statements are a convenient way to insert a debugging assertion into a program. Here it gives the syntax for the statement. The next statement is the pass statement. Pass is a null operation. When it is executed, nothing happens. It is useful as a placeholder when a statement is required syntactically, but no code needs to be executed. For example, definition f, argument, and pass. Now we see the delete statement. Deletion is a recursively defined, very similar to the way assignment is defined rather than spelling it out in a full details. Here are some hints. Delete statement is equal to delete and target list. Deletion of a name removes binding of that name from the local or global namespace, depending on whether the name occurs in a global statement in the same code block. If the name is unbound, a name error exception will be raised. Deletion of a target list recursively deletes each target from left to right. Now we see the print statement. Print evaluates each expression in turn and writes the resulting object to standard output. If an object is not a string, it is first converted to a string using the rules for string conversion. The string is the return. Objects which act like file object but which are not the built in the file object often do not property this aspect of the file object's behavior. So it is based not to ready on this. Standard output is defined as the file object name stdout in the built-in module system. Now we see the return statement. Return may only occur semantically nested in a function definition, not within a nested class definition. Return statement is equal to return an expression list. Return leaves the current function call with the expression list as return value. An expression list is present, it is evaluated as none is substituted. In this way, we see the different type of statement. We learn about the input and output file. Ali is a built-in type in Python. Allow access to less in an operating system independent manner. Direct modes to access a Ali are R is used for opens an already existing Ali in read-only mode. W opens a alley in write-only mode. If alley exists, it is truncated as a new alley in created. A opens a alley in write-only mode. If alley exists, new data in added at the end, else a new alley is created. R plus alley is open in read and write mode, but alley must exist. W plus alley is open in read and write mode. Alley is truncated if exist, else a new alley is created. A plus alley is open in read and write mode. If alley exists, a new data in added at the end, else a new alley is created. Append B to the mode to open alley in binary mode. Modes are passed to function open which is used to open a alley. The syntax is alley object is equal to open and in the bracket alley name mode and bob size is equal to -1. Now we see the file object methods. Let us assume we have f is equal to open alley and r plus. F dot read and into bracket size reads a size byte from alley and returns if size is not specified or if size less than 0 then size reads wall alley. F dot read line reads one line from alley and returns the line. F dot read lines read all lines in alley and returns a list of lines. F dot write writes the data to alley and F dot close the alley. This is the basic information about the file. We will revise the wall Python. Python is a general purpose, object oriented, high level and interpreted language. Developed in early 90s by Judo van Rossum, it is a simple, portable, open source and powerful language. Now we see what we will learn. History, features and basic details, language basics, control flow, functions, modules and file IO. Now we see where it is used. It is used extensively in web, TurboGears plan it's extra. Communicating with databases MySQL, PostgreSQL, Oracle, and many more. Desktop GUI, GTK Plus, Qt, TK, and many more. Scientific computing, Skippy, Scientific Python, and many more. Network programming with frameworks, libraries like Twisted, and many more. Software development, Essions, Build What, Roundup, and many more. Games and 3D graphics, PY Game and PY Chiara. There is a scope of the where Python language is used in very big way. Now we see the difference from C, C++, and Java. There are no pointers, which is similar to Java. No prior compilation to bytecode directly interpreted. Includes a garbage collector. Can be used in procedure, object-oriented approach and style. It is a English-like syntax. It is very good for scripting. Now see the version of Python. What do you mean by version? Python is a language. Python as a language keeps on evolving and new features are being added to the language. Here, by versions, we refers to the Python interpreter version. New features are added to Python interpreter in every release. Important version are Python is 2.6, 2.7 and 3.0 and 3.1. We will focus on Python 2.6 and 2.7 and not Python 3.0 and 3.1. Python 3.0 and 3.1 is the future of Python and has non-compatible change from Python 2.x. Currently, there is a less support of Python. Now we will see the interactive session. What is the interactive session? Allow you to test your idea, logic, code, and play around with it works as well. You can try out almost anything, but whatever you type is not saved. How to start an interactive session. To exit an interactive session, type quiet or press Ctrl D on Unix like machine and press Ctrl Z on Windows machine. First of all, we see the basics of language. Indentation. In Python, indentation is very important. There are no end and begin delimiters like F and G. Grouping of statements are done on the basics of their indentation. Statements at same indentations are grouped together in a single block. It's recommended to use four space instead of tabs. Has mark star of comment for single line. Here we have a simple code on the screen. A is equal to 10. If A divided by 10 is equal to 1, then print I think and print the value was and the value and the print is equal to 10. It is actually print. Now we see the concept of string. There is a no character data type in Python. Strings can be quoted in single slash or triple slash quotes. Special character can be inserted by using the escape character n. Some commonly used escape sequence like double slash for a slash in a string, single slash for in a string, single slash in double quoted for in a string, single double slash for a new line, single slash r for carriage return, and many more. Now we see the tuple. Tuple is an immutable ordered sequence of items. Tuples can be considered as constant array. There can have a nesting of tuples, one inside other. Elements in a tuple does not have to be same type. Assignment to T is equal to 1, 2, 3, 4, ABC 2.34 and 10, 11. Elements can be accessed in way similar to an array. Like example, we initialize T is equal to 1, 2, 3, 4, ABC 2.34 and 10 and 11. Then we have print the T of 0, so the value is 1. And then we print the T of 4, so the value is A, B and C. And when we print the T of 6, then the output is 10 and 11. Now we see the list. List is a mutable order sequence of items. Items in a list can be added or removed. There can have a nesting of lists one inside other. Elements in a list does not have to be same type. Assignment to L is equal to 1, 2, 3, 4, ABC 2.34 and 10, 11. Data access and assignment similar to an array I is equal to 1, 2, 3, 4, ABC 2.34 and 10, 11. So we print the I0, so the value is 1, which is the index 0. And then we print the I6, then the answer is 10 and 11, which is the index is 6. Now we see the dictionaries. Dictionaries are containers which stores item in key value pairs. Dictionaries are mutable but does not have any denied sequence. Key can be any integer or string and value can be any item. As in dictionaries, values can be accessed by using the key. Assignment S to D is equal to F key colon value 1 colon value ABC colon 1234G. Value can be accessed using the key and keys are unique. D is equal to F key colon value 1 colon value and ABC colon 1234. Then we have print the D of Q. So the output is value. And in same way we write the D of 1, then our output is as usual the value. Now we see the index and slices. List, tuple, string, and many more can be sliced to get part of a data from them. Index of similar to array index refers to position of data. Slice used to retrieve data within a particular index. We have a small code s is equal to lug manipal. So we have to print s of 0. So our output is l, which is the index is 0. Then we have the print s of 2. So our output is g because lug means its index is 0, 1 and 2 means the g is situated at position number 2. Then we print the s in the bracket 0 and colon 3. It prints the 0 till to 3 but not including 3. So our output is LUG. Now we see the variables. There no prior type declaration requires for variables. A variable can refer to any data type like tuple, list, dictionary, integer, string, complex, or any other object. Variables are references to allocated memory. References are always said. Use function list and old dict to obtain a copy. L is equal to 1, 2, 3, 4. D is equal to F of key colon LG. Now we print D of key. So our output is 1, 2, 3 and 4. Now we see the dictionary operation. There are many dictionary operations. D dot has key. It is return the true if key by values exist, else return false. D dot items. It returns the list of two value tuple with the rst element key and second value. D dot keys. It returns the list of all keys in dictionary. In this way, D dot values, D dot it returns, and many more operations in Python languages. First, we see input and output. First, input. To take input string from user, we use a function row input. Function input evaluates the input as Python expression. We use function int, long, oat, and str to convert the input to desired type. Now we see the output. Print is a keyword for giving a output to a console or a LE. Print can take a multiple arguments separated by comma. If you don't want a new line, add comma at the end. Now we see the if statement. If is a conditional keyword for a simple if, then else clause in English. Header lines are always concluded with a followed by indented block of statements. Optionally, if can be followed by an else if, which is known as elif in Python. Expression can be logically connected by using or and. Just remember, we need to put where every we use fg in other languages, and statements following if should always be indented. Now we see the syntax of while. While is used for repeated execution of a block of code till a condition holds true. In Python, while has an optional else clause which executes when the condition evaluates to false. Following values are considered as none, false, any numeric type equal to 0, any empty sequence, or any empty mapping fg. Like example, limit is equal to 5, value is equal to 0, then put a condition while val less than limit and colon, then print val. Val is equal to val plus 1, so our output is 0, 1, 2, 3, and 4. Now we see the for loop. For is a sequence iterator for works on string, list, tuples, and many more. Use range xrange to generate a list. Range 0 to 4 means 0, 1, 2, and 3. Range 0, 6, and 2. So that means in between 0 to 6, write by increment by 2. So 0, 2, and 4. Xrange works as a iterator and does not generate a list. Like example, for item in range 1 to 5 and colon and print the item. So our output is 1, 2, 3, and 4. Now we see the break and continue. First we see the break. Use for loop termination. If nested terminates the inner loop, and then continue. It terminates the current iteration and starts the next. It does not terminate the loop. Like example, for I in range 1 and 10. And if I is equal to 6, so then break. If I is equal to 3, then continue and print I. So our output is 1, 2, 4, 5. Now we see the list comparisons. Normal use of for loop is to iterate and build a new list. List comparison simplifies the about task, syntax, expression for target in iterable condition. There can be multiple statements like example x into 2 for variable x in range 1 to 5. So it is 2, 4, 6, and 8. So like this x for variable x in range 0 to 10, if x modulo by 2 is equal to 0 and x greater than 2. So our output is 4, 6, and 8. So in this manner, we assume that the third example. First of all, we see the what are functions. A function is a group of statements that executes on request. In Python, functions are also objects. Function return type is not required. If function does not return any value, default value of none is returned. A function can take another function name as argument and return a function name as in functional programming languages. A function is defined using the keyword definition followed by function name and parameters. Now we see the example of the function. We define a function def abc and in the bracket we pass the argument and print the argument the abc hello. So the output is hello. Now we see the parameters. What is the parameters? Default value is the value assigned to function argument in function definition. Type of parameters. There are two type of parameters. First is mandatory parameters with no default values. Second is optional parameters with default values. Add function call Value for all mandatory parameters are required. There is no function overloading in Python. Like example, def abc argument 1 and argument 2 is equal to 10. Here default value of argument 2. Print argument 1 and argument 2. First of all, we call the function abc and pass the argument only 1, so our output is 1 and 10. But in the second line, we pass the two argument 2 and 3, so our output is 2 and 3. Now we see the what are modules. Modules group code and data for reuse. Modules or a part of modules can be used in other code using import or from statements. First we see the what is the import. We see the syntax for import. Import module and in the bracket as other name. Import imports all of specified module in the namespace module and other name. And now we see from. First of all, we see the syntax of from. From module import something as something else. Using a from import something inside the current namespace as something and something else. Now we see how to make module. Any Python language can work as a module. If the language is written to execute when invoked, it is execute when imported. To allow Ali to execute it when invoked and avoid when imported, we compare variable name. Python language executing as main code has variable name set to main. Python language executing as module has variable name set to the module name. Thank you, friends.